Okay, welcome back. This is Dr. Nigro again. This time, instead of speed, we're going to talk about velocity and the difference between those two terms. All right, so first we have a thought problem. Dr. Nigro needs to go to a restaurant for lunch, but does not know how to get there. You tell her that she needs to travel 3.8 kilometers for 244 seconds at 15.6 meters per second. So the question is, with that information, will she be able to find the restaurant? Why or why not? And what other information might help? All right, so the person giving this information has told me the distance is 3.8 kilometers. Right? They've told me that the time it should take me to get there is 244 seconds. And my speed, the rate at which I travel, needs to be around 15.6 meters per second. All right, so this is useful information, but if you're trying to tell someone where to go, the other piece of information that you need is the direction of travel. All right, it's not enough to tell someone the distance, time, and rate. You need to tell them whether they need to go left or right, east, west, north, south. All right, so we need to include direction of travel as part of our information when we're talking about the motion. All right, so this leads us to two new terms, scalar and vector. All right, in physics, we're going to see these two pop up quite a bit because various variables that we use in our formulas are going to either fall under a scalar quantity or a vector quantity. All right, so a scalar quantity is a number with a unit. All right, so basically all you get about that particular variable is the magnitude, the number. All right, so an example of this is telling someone that they need to move 13 meters from where they're standing. All right, a vector quantity is the number with unit and plus the direction of that travel. So it's the magnitude and the direction. All right, so an example of a vector quantity would be if you told someone they need to travel 13 meters and they need to go to the north. All right, so the difference between our scalar quantity and vectors quantity is this inclusion of that directional piece. All right, so speed is an example of a scalar quantity. All right, the vector version of speed is called velocity. So they're similar in that they both talk about the rate of travel, all right, but velocity must also include the direction in which that travel occurs, all right? So if we look down at our formula triangle, you're going to see something very similar, all right? Velocity, because it's still the rate of change in position, is going to be distance, divided by time, although we really should use the word displacement here instead of distance. But for our purposes, we're going to keep it simple and we're going to keep it distance. All right, if we put our variable symbols in, we're going to have V for velocity, D for distance, and T for time. All right, so again, it's the rate of change in your position, and it indicates your direction of travel as well. All right, so for units, we're going to see the exact same units we saw for speed. The velocity needs to be in units of meters per second. Your distance or displacement needs to be in meters, and your time needs to be in seconds. All right, if we build our formula triangle, we have distance, velocity, and time. All right, where velocity is going to be equal to distance divided by time. Distance is going to be equal to velocity times time. And then time is going to be equal to distance divided by velocity. All right. Now, with our other problems, just like those, you have to watch those units. All right. Make sure that you are keeping an eye on the units of distance and time and that they match those of your velocity value. Okay. So if you're in your car driving, there are really three ways to change your velocity. All right. We can change the speed. So you can increase your speed with your gas pedal. All right. You can also decrease your speed with the brake. Or the one that we don't think about as often, you can change your direction. You can turn your steering wheel. Any of those will lead to a change in our velocity. All right? So we really have three ways within our car to adjust that velocity value. All right? So, as we said, velocity is a vector quantity, and as such, it needs to have a directional component. So sometimes that can be north, south, east, west. You could say right, you could say left, you could say up, down, forwards, backwards. All right, we also tend to use signs to indicate change in direction. So we'll use a positive sign or we'll use a negative sign, and we define in class what those mean. All right, the sign tells us that direction of motion. It doesn't mean that the velocity is greater than or less than 0. It just indicates which direction that motion is occurring. All right, so for positive velocity, we have defined that in class as forward motion. All right, we've also defined it as upwards motion. All right, so if you have a person and that person is moving forward, all right, we say that they are moving in the forward direction. Sorry about that. Forward direction, which means their distance is changing in a positive manner. All right, we say that the velocity value should be positive. All right, if instead you have a person and they are moving backwards, all right, we say that their distance is negative and they have a negative velocity value. All right, this could also be up or down. Oh, sorry. Negative velocity is also always down. So it's either backwards or down. And those are just conventions we have decided to do. All right, now just like speed, velocity can be described as average velocity. It can be constant velocity or instantaneous velocity. All right, so let's talk a little bit about each one of those. All right, remember for average speed, that was your total distance, right, divided by the total time of your trip. Hold on, let me fix this. All right, and we had a formula for that. S with a line over the top equals D total divided by T total. All right, if we think about velocity and average velocity, it's the same thing. It's total distance divided by total time plus direction. So we have to include that directional piece. Did we move forward? Did we move backwards? East, west, north, south? All right, and so our V average formula is the same as for speed, D total divided by T total, but we just need to be sure to include which direction our object is moving in. All right? All right, instantaneous, all right, just like we saw before, instantaneous speed is the speed at a specific point during our motion. All right, and as we said before, to check it, look at your speedometer. All right, nowadays the speedometers are digital, so it should be pretty easy. All right, so if you look at your speedometer, that will tell you your instantaneous speed. All right, instantaneous velocity is the speed and direction at a certain point during your trip. All right, so our speedometer still works here, all right, but we also need to know what direction we are moving in, all right? Now, some cars have those, and they'll tell you which direction your car is moving, all right? But if not, you can use your eyes and figure that out, all right? Constant speed, all right? Just like we saw before, constant speed means speed is unchanged throughout your trip. All right? For constant velocity, your speed and direction are unchanged. Throughout your trip. All right, so the key here is that inclusion of direction. All right, so when you're working problems and answering questions, you need to be aware of whether you are working with speed or velocity, all right, because that's going to tell you whether you need to include direction in your answer. You also need to watch out for terms like stopped, average, and constant, because these are important context clues. All right, remember, just like speed, if you have, if you have a constant velocity, then that value equals your average and instantaneous velocity values. So knowing that you're moving at a constant velocity or a constant speed is actually a really nice piece of information. It tells you a lot. All right? All right, so that's it for our look at velocity. All right, in the next video, I'm going to talk about what happens when your velocity changes.